Hello, friends. I hope you've had a good weekend. We continue with our lesson with mathematics. Where we ended last time. Okay. So we're looking at our sequences and series. This is one of the most important of the topics because you find it here in your papers, and it's there both in paper 1 and 2. The last time at maths I explained, but now I've extracted some questions from past papers. There are certain things I want to explain so that after explaining, I may actually send an exercise. Okay, so this question is actually extracted from some past paper, and this is how questions usually come, right? And here is how the question reads. The first three terms of a geometric progression are, there's 1, 2, what separates these is the comma. So there's the first term, second term, third term, okay? And the saying k is a positive integer. Now, there's something that has been introduced that I do not really explain in the first video, what they're saying geometric progression. And you should know this, you should know the difference between a geometric progression and an arithmetic progression. Geometric progression usually comes in paper 2. And for geometric progression, that is where you're going to find this R, which is the common ratio. Okay? Let me give you an example based on what I explained last time, though I did not really explicitly say that you will need to understand this, but let me give an example. If you have 2, and then you have 6, you have 18, and again you have 1, 3, 5, 7. I want you to check the difference between these two. So for me to get from 2 to 6, what have I done? I've multiplied 2 by what? By 3, right? How about me to get to 18 from 6? What have I done? I've multiplied 6 by 3, right? Now, if I'm to change, I say 6 divided by 2. What am I going to get? 3, right? This into that. In short, the previous term into the term we're looking at. If I can put it that way. It has given me what we call the R. This is the common ratio because throughout are the same thing. If I'm at 18 here, what is 18? I'm looking at 18. I divide by the previous term, which is 6. I'll still get the 3. And the 3 is what we call the common ratio. This is what we call this is what we call a geometric progression. Geometric progression. You're going to have the common ratio. Okay, it's common because here you have 3, even here you have 3. 2 into 6, you're going to have 3. 6 into 18, you're going to have 3. Now, if I look at the following here, from 1 I've moved to 3, what have I done? I've only added a 2 to 3, right? So here, from 3 to 5, I've also added a 2. And equally, from 5 to 7, I've added what? A 2. So here, there's what we call the D, which is the common difference. Why? Because if I say 3 minus 1, 3 minus 1, I'll get what? I'll get a 2. The term I'm looking at minus the previous. 5 minus 3, I'll have a 2. Therefore, the 2 is what we call the common difference, which you just refer to as D. So, this one is an arithmetic progression. And this is what you usually find in paper 1. I explained last time about this, right? So, you should know the difference between a geometric progression and an arithmetic. For a geometric progression, you're going to have the R, which is the common ratio. But for an arithmetic, you're going to have the common difference. And you should take note of the fact that for the most part in papers, you will find the arithmetic progression in paper 1. Usually it carries less marks, maybe 2 marks or so. But for the geometric progression, you usually have more marks. Okay, so now we're dealing with something to do with paper 2, which is a geometric progression. And I've explained how to find R, which is the common ratio, right? Which is 2 into 6 or 6 into 18. In short, the term I'm looking at divided by the previous term. These are terms. It's the first term, second term, third term. I explained what separates terms are the commas, okay? Now, they're saying the first three terms of this GP. There's K plus 4, okay? Then there's K. And then the third one is what? 2K minus 15. And they're saying K is a positive integer. And the first question is find the value of K. Okay, so there are how many terms here? There's 1, we have a comma, then 2, another comma, I have 3 terms. How do we find the K? For us to find the K, you simply have to find what we call the R, the common ratio. And for me to find the common ratio, like in the example that I gave, where I have, for instance, I have 2, 6, 18. How do I find the R? 6 divided by 2, which is 3. And again, 18 divided by 6, which is what? 3. So now, do you get the logic? Term I'm looking at divided by the previous. So I'll do the same here. I'll do the same. I'll say K, which is the term I'm looking at, divided by the previous. The previous is K plus 4. So R equals this. And again, R equals this term I'm looking at, which is 2K minus 15, divided by the previous term, which is K. So you have 1, 2, 3 terms here. This is how I can get the R. In short, what I'm trying to say is this equals that, right? You're seeing the equal sign there. It's what you have here. Okay. So I can simply say, okay, K times K, this will give me K squared being equal to this here, K plus 4 multiplying by this, 2K minus 15. Okay. And therefore, K squared will equal what? This must multiply with everything inside here. So I'll start with this. K times 2K. That will give me 2K squared, right? And then again, K times this, then K times 15, there's negative there, to be 15K. So I've multiplied K with everything inside the brackets there. And equal, I'll do the same for the 4. The 4 must multiply with everything here. So 4 times 2K, this is positive, so I'm going to have 8K. And 4 times negative 15, that will be negative 60, right? Always look at the left side for you to get the sign. Okay, it's very important. So I have K squared. I can collect like terms here. I can say K squared. This will come here from being, this is positive here, right? It will become negative once it crosses the equal sign. So it will be negative what? 2K squared, like that. Being equal to, these are actually like terms. This is 15K and this is 8K. This is negative. Always get the sign from the left side, okay? So negative 15 plus 8. What do you get? You're going to have a negative what? Negative 7, right? Negative 7K. Then this is negative 60, like that. Okay. K minus 2K. This will give me negative K squared being equal to negative 7K negative 60. I can bring this other side here. I'm going to have this coming here to be positive, right? So I'm going to have K squared negative 7K negative 60. Reaching this point, I have to factorize. Okay. I simply have to factorize. I need to find the value of K. And how do I factorize this? You know that, right? Where I say you do this, you say product sum factor. Okay, so now when factorizing, when I'm at this stage, I must make sure that the one with a square is at the first here, for it to be what? To be A. And the one with just a variable, when I say a variable with a letter, which is not squared, must be in the middle. And then a number, which is a constant. A number, just a number without any letter, must be at the end. So if it's not in this order, make sure you arrange it in this order. That's why I've arranged it. Okay. And therefore, having said that, let's now find the product. What's the product? What's the coefficient here? The coefficient of k is 1, right? 1 by this negative 60. 1 times negative 60, that would be negative 60. What's the product? What's the sum? The coefficient of the middle term. First term, second term, third term. So what's the coefficient here? It's negative 7, right? Now, we have to find numbers where the numbers which, if we multiply those two numbers, will give us negative 60. Will give us this product of 60, okay? However, those two numbers, those same two numbers, if you add them, they must give us a sum of negative 7. Which numbers are those? What do you think? I'd love to think those are the... which numbers are those? I think it's 12 and 5. Negative 12 and 5 actually. Because negative 12 times 5 will give me negative 60. However, negative 12 times 5 it will give me negative 60. That will be the product if I multiply these two. However, if I add this same two, negative 12 plus 5, I'll get negative 7. So having done this, I can simply say k squared. Then this must go to be replaced with this, or by this. So I'm going to have negative 12, then I'll say k. Then this is plus 5k there, this is positive 5, right? Negative 60. So now here's where I can do the whole thing of factorizing now. So what's the common factor between k and 12k? Of course, k is common to both, right? So I'm going to have k like that. Now, what I put outside the brackets, I divide into both. So k, I've put it outside because it's a common factor. K into k squared is like having k squared divided by k. K squared means k times k divided by k. So this and this must cancel. Therefore, I'm going to have k only remaining. Therefore, I'm going to have k here. Then again, k is negative here. K into 12k. The k and k will cancel. I only remain with a 12. I'll factorize this part. Then now coming to this part, what's the common factor between 5 and 60? I don't have to put the brackets here. 5 and 60, what's the common factor? 5, of course. I don't mind writing. So I must have a 5 here. Then you open bracket. Okay. Right, so what's next? What must follow? What I put here I must divide into both. So 5 into 5, that will be 1. Right? What next? 5 into negative 6, that would be negative 12. Oh, sorry, this must be 5k here. How have I missed it? Must be 5k. So 5 into 5k to be 1, then the k will be here. So if you factorize it right, like I have done, what you are going to have inevitably is a common in both brackets. You see, you have k minus 12, you have k minus 12. This is where you judge if you're right or wrong. So here we'll factorize it Alright, because what we have in the bracket is the same. Therefore, get a pair of the bracket, which is k negative 12, not both, but just get a pair. So I have k negative 12 like that, okay? Then these, group them into brackets. So k, this is positive 5, so k plus 5. K plus 5. And then I'll equate to 0. Now, what I have here, I simply have to equate to 0. What I have in the brackets, I equate to 0. So I have k minus 12 being equal to 0. Therefore, k being equal to, if the 12 goes the other side from being negative to positive. If I get this here, I'm going to have 5 and k plus 5 being equal to 0. Therefore, k will equal to, the 5, if it crosses the equal sign, from being positive to be negative 5. Now, go back to the question. They're saying k must be a positive integer, meaning it must be positive. Here is negative, so the answer that they want here is this. Therefore, k is 12, okay? K equals what? 12. You have to make sure to get the first question right. We've gotten it right, so this is our answer here. Don't worry, I'll send the notes of this. This is just meant to explain. The video is there to explain, is here to explain things, okay? Do you have anyone with problems up to this point? I don't think so. Play and replay the video. We got the second question. We found the value of k. And this is the most important part, because once you get the first question wrong, automatically, even the questions which follow, you are likely to get them wrong because they're connected to the first question. Okay, now these are the terms that we have, right? K plus 4. Then the second term is k. The third term is 2, k negative 15. Now let's go to the second question. What is it saying? List the first 3 terms of the geometric progression of the GP. List the first 3 terms of this GP. So we actually have the 3 terms of 1, 2, 3. Remember, what separates the terms are the commas. So now, here it's all about now substituting where there's k. We're saying k is 12, right? So if k is 12, I'm going to have 12 plus 4. Then here 12, then here I'm going to have 2. K is 12, negative 15. So this would be what? This would be 16. I'm adding 12 plus 4 is 16. Then here I have a 12. Then here I have 2. This is 2 times 12, which is 24. Then 24 minus 15. 24 minus 15, that must be 8. It must be 8. So you would have found your answer. Now, imagine if you had gotten the first part, the k, wrong. Then definitely even this would be wrong here. Because instead of having 12 over this k, maybe your answer would be something else. Moving from B, we go to C. Find the sum to infinite. Now, this is the formula that you use. Finding sum to infinite of a geometric progression. I've explained what a geometric progression is. If you haven't understood up to this point, please try to play and replay the video, or you can inbox me, you can ask. Okay. Although this time around, I don't want to use the short videos like the ones I sent last time, because these are connected. It's better you view them in a single video like this. You watch in a single video. So I'll just send the link on which after you tap, you'll be directed to the actual video on YouTube. Okay, I'm starting to use YouTube because sometimes I think it's convenient. Last time I tried to use Chino, but some of you couldn't access the videos. Then find the sum to infinity. This is the formula that I use. The formula I use to finding sum to infinity, to say sum is for sum to infinity. Use this symbol. Sum to infinity equals, this is a formula. You should memorize this. Actually, I think in the paper 2, you actually have formulas. You have the formula. Is it right English? If I say formulas, formulae, anyway, whatever. But there's that part before you start your writing of paper 2 in maths, where you have the different formula. So here you have this. You need to know, if you don't know those formula, even if you're given those formula, you can't really know where to use them, when to use them. But if you understand, like here, it's easier. But you can memorize this. So the formula to finding sum to infinite of a GP, geometric progression, equals A over 1 minus R. A is the first term, R is the common ratio. So here I'm going to have, what is A? A is the first term. The first term is A. So what's the first term there? I found it to be 16, right? 12 plus 4, it was 16, right? So first term is 16, dividing by, then 1 minus, what is the common ratio? What is the R here? For me to find the common ratio, I simply say, the term I'm looking at, which is 12, dividing by 16. How do I find the answer here? 4 here, 4 here, 3. So I'm going 3 over 4. If I want, I can simply say I'm looking at this term, which is 8 minus 8 divided by 12. 8 divided by 12. 2 here, it would be 2. No. Let me use 4. Okay. Let me use 4. 4 here is 2. 4 here, 3. So I have 2 over 3. I better use this part here, which is 12 divided by 16. 12 divided by 16. Well, we found this, right? 4 here is 3. 4 here is 4. 3 over 4. Okay. So I have 3 over 4 is my R there. 16 dividing by this, which is 1 minus 3 over 4. So I'm going to have 16 dividing by, this will give me what? It's as good as over 1 here. 4 is a common. That's the lowest common multiple, right? 1 into 4, 4 times 1 is 4. 4 here, 1 times 3, which is 4 here is 1. 1 times is 3. So I'm going to have 1 over 4 minus 3 is 1, right? Then over 4. So I'm going to have 1 over 4. So I'm going to have 16 over 1. So any number is as good as that number dividing by 1. If I have 5, it's as good as 5 over 1, okay? So if I'm multiplying here, then what I have here must change. It must be reversed. The bottom part must be the top part. So in short, the 4 will be on top, then I'm going to have 1. 16 times 4, that's 64. Then here, this will give us 1, right? So 64 is therefore the answer here. That is the sum to infinite. So when I find the sum to infinite, you simply have to identify what the first term is, the A, then 1 minus R, which is the common ratio. For you to get the common ratio, simply say the term you are looking at dividing by the previous term. And basically that's it, and this is what I'll end for today. I've ended here because the other part I'll explain it tomorrow. If a question comes slightly different from this that I've explained, because usually you find the question in this format, but sometimes just slightly different. So I'll explain the other version next time. Tonight, this evening, I just want to send you an exercise and see if you really followed everything. Okay. Thank you and wishing you a pleasant evening. Those of you owing, do the thing today, send me the money. And those of you with friends who may want to join, please tell them to join because you know what you're learning, right? These are things that you find in your exams. Okay. Thank you. Feel free to inbox me